Hi, my name's Travis Mull, and this is Larry Peters. We're here today to present to you this hotline demonstration provided to you by Hoosier Energy. We're going to talk about electricity and, more importantly, how to be safe around electricity. And what this is actually is a scaled down version of the actual power lines that Larry and I work on a daily basis. You'll notice that the wire up here, all the equipment, the material is exactly the same as electricity lines that Larry and I work on. Obviously the poles are shrunken where you can operate and see it, so we even have the same voltage on our power lines as what the real power lines running up and down the road have. Now let me take just a minute and talk to you about generator safety while we're talking about backfeeding on transformers. Because what we've done here with this transformer, if you're not careful, you may do yourself without knowing it. When Larry and I are out working at night and we have whole lines of electric out, we see one home that has lights, that immediately sends up a red flag to us. We know that that home most likely has a generator. And if that generator has not been installed properly with a proper transfer switch, you could inadvertently be putting electricity back onto our power lines. And that could be very problematic for Larry and I, and it could also be very problematic for your neighbors. If your neighbor sees a line lying down on their road, or on their driveway, they want to move it so they can go to work. They've been down to grab it, not knowing that you're putting 7,200 volts of electricity back on that line, then you've just caused them damage or harm or maybe death. So be very careful if you use generators. Ensure that they have a proper transfer switch on them that isolates them from the power grid. Now I have a button here in my hand. This is a hot button. We call this a hot button. Anytime I want that unit to become energized or hot, as I might say, I have to depress this button. Only when I have this button pushed is this line going to be hot. Now, but anytime I push this button, I'm going to tell Larry it's coming hot, so he will in fact know that the line is energized. We also have a light down on the far end there, and we're going to use that light to represent your home, the lights in your home. Anytime you see that light on the end on, that means the unit is energized. Now, in order for Larry and I to know if a line has been energized or not, the first thing we're going to do is take a voltage indicator or a tester, and we're going to test that line to see if it in fact is hot. And that's what Larry's going to do. I'm going to energize the line. He's going to put a tester on it. And if the line is energized, you'll hear an audible beep. Coming hot, Larry. Now you can hear that audible beep. That tells me that that line is in fact energized. Now, if I did not hear the beep, would that mean that the line is not energized and safe to work? Absolutely not. That piece of equipment there, that tester, is just a piece of mechanical equipment. It can and does fail from time to time. So we have other safety precautions, but that's our first line that we use there. I have here in my hand a report from Federated Insurance. And this report tells us that the number one reason that the public comes into contact with power lines resulting in fatalities and injuries is antennas, ladders, and poles. And we see a lot of people with aluminum step ladders or aluminum extension ladders. We understand aluminum, it's a little bit lighter, it's easier to work with. But the problem is that aluminum is a very good conductor. Electricity is looking for a way to get to the ground. That's what it wants to do. And that aluminum ladder would offer a very good path to the ground. Now we have here an aluminum ladder. We still see a lot of aluminum ladders out there on our system. Aluminum is a lighter weight material, it's easier to use. Extension ladders are substantially lighter when they're made from aluminum. Now Larry's going to demonstrate here what happens when it comes into contact with 7,200 volts of electricity coming hot. What you just saw there was an electrical arc. Now electrical arc in essence is the metal from the power lines from the ladder instantly evaporating into a gas. And scientists tell us that that can happen at up to 35,000 degrees. 35,000 degrees is roughly 4 times the heat of the sun. So what you just saw there could have been up to 4 times hotter than the sun's surface there. It's electrical arc. Another thing that we have concern with all the new satellites that are coming in, all the cable television, a lot of people are wanting their old television antennas down. The big tall 30, 40-foot television antennas, they're wanting them brought down. And unfortunately, some people take this upon themselves. They don't call the power line company. They don't notice there's power lines around them. They'll get one of their buddies to hold on, they'll cut it off, and they'll try to let it down. Unfortunately, it doesn't always work well for them. Sometimes the wind gets away from them, or they're heavier than they may have anticipated. Larry's going to demonstrate what happens when we get an antenna into the power lines. Again, that's 7,200 volts of electricity at up to 35,000 degrees. The electricity was running down that pole at the speed of light. We know the speed of light's about 186,000 miles per 1 second. So if you had been holding on to the bottom of that tower when that electricity entered that, it would cause very substantial injuries, if not death. In addition to things being raised up into the power lines coming in contact, we also have to be concerned with things falling down from the power lines coming into contact with the public. And that's the situation here. This is a guy wire. And you'll see guy wires that are attached to the top of poles. And they'll go from the top of the pole down to the ground. They hold poles in specific positions where we want them to keep them from creeling over. Unfortunately, it happens a lot of times that vehicles drive into the bottom of these guy wires. They break them off from the ground, flip them up over the energized conductor. This guy wire could be hanging down at 7,200 volts unbeknownst to you. And that's exactly what happened to this particular guy wire I have in my hand. It came into contact with the 7,200 volt electric line. A young man had a hold of it down here. That young man suffered severe injuries, and he later died from those injuries. If you see a line hanging down from the power lines, by all means call the electric company. We'll come out, we'll take care of the situation and make it safe. Now, we're going to use a hot dog to simulate a human hand. There's a lot of similarities between a hot dog and my hand. It's about the size of a human finger. There's a lot of the makeup of it is the same, meat and things of that nature. And one thing that we can talk about is the moisture content of this hot dog. The United States Department of Agriculture mandates that a hot dog can be no more than 10% water, as opposed to you and I, a human body is about 60 to 70% water. And we know that the water is what makes us such good electric conductors. So in essence, you and I are 6 to 7 times better conductors than what this hot dog would be. Larry's going to demonstrate what happens when a human hand comes into contact with 7,200 volts. Coming hot. Now, you would think this hot dog would be too hot to handle it after 35,000 degrees, but that's not the way electricity works. Electricity actually cooks from the inside out. So if we were to open this hot dog up, slice it long ways, we would most likely see substantial damage inside of this hot dog. When you come into contact with a power line, most likely it's going to go in one spot and it's going to come out another. You may not have noticeable damage on the outside. All the damage is being done inside. Your muscles, your tissues, your fat is being burnt from the inside out. Larry and I recently heard about a coworker from a neighboring cooperative, electric cooperative, come into contact with a power line. 3 days after the initial contact, they end up removing both his hands between the wrist and elbow. So this is a very serious situation. In order for Larry and I to safely work on these power lines while they're energized, we have to put our safety gear on. The first level of safety for us are these rubber gloves. By putting these rubber gloves on, we're able to go up in a bucket truck, an insulated bucket truck, and safely grab a hold of an energized conductor. Larry's going to demonstrate to you how we can safely go up and grab a hold of an energized conductor with our rubber gloves on. Coming hot. It's pretty scary. The problem with that rubber glove right there is it had a small pinhole in it. Very, very small hole, very hard to detect. Larry did not inspect that rubber glove before he put it on. One of our first and foremost safety rules that we follow is that each and every time before I put these rubber gloves on, I'm going to pull this glove out of this leather protector and I'm going to inspect it. I'm going to check every inch of it. Make sure there's no cuts, tears, snags, abrasions of any sort that could let electricity flow through it. I'm going to inspect this glove like my life depends on it, because in fact it does. Larry has another glove. Now he's inspected that glove. He's checked it. He knows. He's willing to bet his life that that glove is good. Show us what happens on a good glove, Larry. Coming hot. As you can see, he's making contact between the neutral and the 7,200 volts. Nothing happened. We're going to talk about some things now that can make the electricity go out, that can flash your lights. The first thing we're going to talk about may not be the most obvious thing that you would think of when you think about electric outages. That's a mylar balloon. A mylar balloon basically is just made from thin aluminum foil, which again conducts electricity very well. People get mylar balloons for their birthday, for their anniversary. After the news wore off of them, they take them outside and they let them go. Up and away they go. Unfortunately, a day or two later, they start losing their helium, they start coming back to Earth. If they find their way into a substation or an area where a lot of electricity is generated, they can cause massive amounts of damage. Larry has a mylar balloon loaded. He's going to demonstrate what can happen when it comes between an energized conductor and something that's attached to the ground. Unbeknownst to you, that mylar balloon that you stepped outside and let go with little or no thought has come down in a substation. Now a whole city block is dark because of that mylar balloon. We've incurred extensive expenses because of that mylar balloon. When you get done with your mylar balloons, let's take something, poke a hole in them, let's put them in a recycle bin. Don't let them go, please. Something else that we have a lot of problems with is tree limbs. Tree limbs cause an enormous amount of our outages. You're driving down the road, you see a tree laid against the power lines, you say, well, I can get out and move that. It's a small tree, it's made out of wood. The power line poles are made from wood. Obviously, they don't conduct electricity. You reach out, you grab a hold of the power line, or reach out and grab a hold of the tree, you discover that in fact that tree is energized because the tree is full of sap, which is mostly water. And water, again, is what makes us very conductive. Now, Larry has a piece of a branch here that he's cut. He's going to demonstrate the conductivity of a branch. Coming hot. If you would have grabbed a hold of that branch right there and when it was conducting, when it was in touch with that 7,200 volts, that 7,200 volts would have entered into your body, causing massive damage, if not death. So if you have trees in your backyard, they're growing up through the power lines, please give the REMC a call. We'll be glad to come out and trim them down. Don't let the kids play in them. Don't hang tree swings on them. Don't hang tire swings on them. Stay away from them. Give us a call. We'd be glad to come out and clear the situation up. Let's talk about something else here for a moment also. On a very regular basis, we have automobile accidents where people drive into our poles. People are driving down the road, they're not paying attention, they get on a little bit of ice, they run off the road, next thing you know they've hit an electric pole, they have a pole broken down on their car, there's power lines lying on their car. Now how do you know if those lines on your car are a power line, or a telephone line, or a cable line, or a fiber optic line? And you don't know. How do you know if it's a power line? Is it energized? Is it de-energized? You don't know that either. If you, in a car wreck, you have a pole, you have power lines on your vehicle, the safest thing you can do is stay in the vehicle. Pull your phone out, call 911. And 911 will dispatch the ambulance, the police officers, maybe first responders, and they'll call us. Now we put on a safety presentation for first responders, for police officers, for firefighters, and we bring them in and we talk to them about this exact thing that we're talking about here. We tell them, if there's a line on the vehicle, stay away. Wait till the electric company has come and determined the scene is safe before you grab a hold. Say you don't listen to that, you see the line on your vehicle, it's an energized line, you decide you're going to step out. Larry's going to demonstrate to you what can happen to a rubber tire that comes into contact with 7,200 volts. Coming hot. If you still think rubber tire is going to insulate you from 7,200 volts, it's not going to, is it? It may for just a second, it may for just a minute, but eventually that voltage is going to find its way through that tire. There is one situation where you may have to get out of that vehicle. That's if someone in the vehicle is hurt, maybe the vehicle's on fire. If that's the case, then you will have to get out of the vehicle. There's really only one safe way you can do that. That's to open your door up, look around, look for hazards, look for other lines maybe on the road. You see no hazards, you jump out of your vehicle. Do a bunny hop, both feet touching the ground at the same time. That's the only safe way that you can exit that vehicle. Once you get out of the vehicle, you're still not completely out of the woods yet. We need to continue to bunny hop or to shuffle your feet as far away from that vehicle as you can get, because we don't know how far that electricity is dissipating in that ground. It could just be a few feet, it could be 100 feet. We don't know. Is there concrete? Is there rebar in the concrete? Are there guardrails along there? Is there much moisture in the ground? All these things need to be taken into consideration. So bunny hop or shuffle your feet until you can't do it anymore to get safely away from your vehicle. One thing that we see a lot of, we have a lot of problems with, are animals on our lines. It's very common for us to get called out for squirrels, for raccoons, for possums. We found snakes on lines. We've found a lot of different kind of animals on our power lines, and they cause a lot of problems for us. And they're probably one of the reasons that your lights go out or your lights flash on a regular basis. We do what we can as a cooperative to keep animals off of it. We put protective pieces of equipment on where we can, but inevitably they're going to find their way up there from time to time, and they're going to knock your lights out. And we're going to explain that to you in just a moment here. Larry has a small squirrel over here that he's going to use, and the squirrel's going to get up on this piece of equipment here on the right. It's another transformer. Larry has a squirrel here that he's using to demonstrate with. Say it's a cool morning, that squirrel is a little cool. He knows that transformer, that gray canister there, has a lot of heat on top of it. So he's going to climb up top of there and he's going to warm himself up on the top of it. He gets warmed up, he's decided he's had enough. He's going to bush his tail up. Unfortunately, his tail comes into contact with an energized conductor. You can see what happens when that happens. Now what you just heard there was a fuse blowing. You can see this gray tube over here is falling down. Inside that gray tube was a fuse link. That fuse link was loaded with a small amount of gunpowder. The gunpowder helps it come open and clear itself. The squirrel is most likely dead, and your line is also. Larry or myself, one of us would have to come out and re-energize that line. Now, one concern that I hear, one complaint that I hear on a very regular basis as I'm out working is that my lights were flashing. Last night, my lights flashed. And that's very frustrating as a consumer. We understand that. But our system is actually designed to flash the lights, and I'm going to explain to you why. This next piece of equipment that you see over here, this gray one, is called an oil circuit reclosure, or an OCR for short. Now what this OCR does, it will sense that there's a problem on that line. It will sense that that squirrel has climbed up there. It will sense that a tree line is on the line. It will sense a problem on there. And what it will do momentarily will open the line up. Hopefully, that whatever the problem is will have a chance to clear itself up. Because we know when electricity causes our muscles to contract, there's no way to let go. Well, when the OCR turns the electric off momentarily, hopefully the squirrel, whatever it is, won't be able to let go, will fall in the clear. And the oil circuit reclosure re-energizes the line. If the oil circuit reclosure knows that there's still a problem, senses a problem still on that line, it's going to turn the electricity off again momentarily. If it notices there's still a problem on the line, it's going to turn it off again, this time for just a little bit longer. It's going to turn back on. When it comes back on, if there's still a problem on the line, it's going to shut off and it's going to stay off. And someone like Larry or myself will have to come and re-energize the line. We're going to demonstrate that for you now. So if you'll turn your attention to the light down there on the end, and watch how it flashes when Larry makes contact. Coming hot. Line is energized. Contact, it's out. Back on. OCR make a thumping noise. What's happened now is there's a yellow handle that's fallen down on the OCR. When Larry and myself pull up, we see the OCR yellow handle hanging down. We know that somewhere beyond that point, there's probably a serious problem. Most likely a tree has fallen through the line, the car has hit the lines are down on the ground somewhere, causing substantial damage. And it's going to be a little bit before your electric's back on. That's our safety presentation we have for you today. We appreciate your attention, and we hope that you've picked up something that you can learn that will help you safely interact with electricity. Thank you.